All right. Come to question number 8. Now, in today's class, I have indicated that instead of cis and trans, we can follow EZ notation for geometrical isomers proposed by Kahn, Ingold and Pralog. Similarly, for optical isomers, we can have this notation or S notation, or for rectus, that means right. S for sinister, left. So instead of dextroisomer and levoisomer, we can follow this sort of notation also, RS notation for optical isomers. Please remember RS notation for optical isomers and EZ notation for geometrical isomers. Since I have mentioned the names of the three scientists, Kahn, Pralog and Ingold, the same rules are followed here also. The priority rules which we have seen for EZ notation, these sequence rules or priority rules are followed in assigning RS notation for optical isomers. Now here also what you have to do is, let us first of all consider A. Here this is the asymmetric carbon atom or chiral center. Always it is better to bring that particular atom having the lowest priority. You can notice bromine, nitrogen, carbon and here hydrogen. That means hydrogen has the lowest priority. So of the four substituents, hydrogen has the lowest priority 4. All right. What will be having the first priority? Of these three, bromine, nitrogen and carbon, bromine will have the highest atomic number. So first priority is for bromine. Second, nitrogen. Third, carbon. So fix the lowest priority for hydrogen, and always it is better to bring hydrogen to the bottom, which I will explain further in other two cases. Now consider this. Now you look at this molecule and you rotate your eye from 1 to 4. 1, 2, 3, 4. So your eye will view this from 1 to 4, and this arrow indicates the priority sequence is in the clockwise direction. Right side arrow I have put. If it is the clockwise direction in which your eyes move along priority number 1 to 4, since it is clockwise, right hand side rotation your eyes movement, and so it is assigned the notation R. This isomer is denoted by R. All right, the same rules we follow here. But in this case, as already I have mentioned, it is better. Again, hydrogen will have the lowest priority. But I have told you it is better you bring this hydrogen to the bottom. That means you should not cancel off chlorine and put chlorine here and hydrogen bring here. That you should not do. One way of bringing hydrogen to the bottom is you fix the substituent at the top. You fix it in that position. Now, in what way you can bring this hydrogen to the bottom? Now, if you move this hydrogen in the clockwise direction, you keep this as fixed. Move hydrogen in the clockwise direction. At the same time, these two will also move correspondingly. You see whether my discussion you can follow. Keep this top substituent fixed. Now bring this hydrogen from here to this position. This chlorine will move over here and the CH3 will come to this position. Do you follow? If hydrogen is on the right hand side, in order to bring it to the bottom position, now in the clockwise direction you rotate, keeping the top substituent fixed. So hydrogen comes to this place, chlorine here, and CH3 will move over to this place. Now again, according to the priority tool, the lowest priority order is for hydrogen. Then, of these three, chlorine will have the first priority because of higher atomic number. Consider these two. Here also carbon, here also carbon. Since both the atoms are carbon atoms, how to fix the priority? Because both the carbons will have the same atomic number. If the first atom will have the same atomic number, you go in for the second atom. In CH3 you will have, you see, these are the second atoms, 3 hydrogens. But consider this, it is CH2, CH3. That means the second atoms will be 2 hydrogens and 1 carbon. But here all the 3 are hydrogens. Since 1 carbon is present here, this group will have a higher priority. So 2, this is 3. Now again you move your eyes 1, 2, 3, 4, again clockwise direction. So this will be R. So this compound A is given R notation, B is also given R notation. Now come to molecule C. Now here hydrogen is at the top. So what you have to do is, as we have seen in the previous problem, you rotate this molecule with respect to this carbon in the plane through 180 degrees. You rotate C through 180 degrees. When this hydrogen at the top will come to the bottom, COOH will move to this, CH3 here, C2H5 here. So if hydrogen is at the top, you rotate this molecule with respect to this axis on the plane of the paper through 180. H will come here, C2H5 there, and COOH and CH3. Now again you look for the priority order, lowest priority for hydrogen. All right, C. All the 3 substituents will have the first atom as carbon. So with the help of first atom you can't decide the priority order. So you go in for second atom. Here 2 hydrogens, here 3 hydrogens, but here the second atom will be oxygen. So which will have higher priority than hydrogens or carbon. So this is 1. As we have seen in the previous case, this is 2, 3. Again you can notice your eye will move from 1 to 4 in the clockwise direction. So this compound is also assigned R notation. So whether it is EZ notation or RS notation, Kahn, Prolog, in goal sequence rules are to be followed, which are based on the higher atomic number atom given higher first priority, like that. We follow.